Hey everyone, welcome back to BugNoJutsu. In today's video, we're going to tackle a classic and surprisingly common interview problem, checking whether a number is a power of 4. At first, this might look like something you can just guess by looking at the number, but there's more to it. We'll break it down step by step so you not only know how to solve it but also understand why the logic works. I'll show you my beginner-friendly loop method first, and then we'll level up to a lightning-fast bitwise trick. The problem statement is simple. Given an integer n, we need to determine if it is a power of 4. In other words, there should be some integer x such that 4 raised to the power x equals n. If this is true, we return true, otherwise, false. Powers of 4 grow quickly, starting from 4 power 0 which equals 1, then 4 power 1 equals 4, 4 power 2 equals 16, 4 power 3 equals 64, and so on. Our job is to see if the given number fits perfectly into this sequence without skipping any value in between 0.9. Let's take an example. If n equals 16, the sequence of powers of 4 is 4 power 0 is equal to 1, 4 power 1 is equal to 4, 4 power 2 is equal to 16. Since we find an exact match here, we return true. Now, if n equals 12, we start again from 4 power 0 is equal to 1, 4 power 1 is equal to 4, 4 power 2 is equal to 16, and 4 power 3 is equal to 64. 12 never appears in this list, so we immediately know it's not a power of 4 and return false. In my loop-based method, I start with an exponent value of 0, representing 4 power 0, and gradually increase it step by step. For each exponent, I calculate the value of 4 power I and compare it with n. If it matches exactly, we've confirmed n is a power of 4 and we return true. If at any point the calculated value exceeds n, we stop immediately and return false because powers of 4 only get larger from there. This approach is very beginner-friendly and easy to understand because you're literally generating the sequence until you either find the number or overshoot it. The loop method takes about log base 4 of n steps in the worst case, giving it a time complexity of O, log n. Since we're only using a couple of variables and no extra data structures, the space complexity stays at O, 1. Now let's look at the bitwise method, which is much faster. Here's the key idea: every power of 4 is also a power of 2. In binary, powers of 2 have exactly one bit set to 1, so we can check this using n and n-1 equals 0. But that alone isn't enough, because powers of 2 like 8 are not powers of 4. To filter them out, we use another trick: n-1 is always divisible by 3 for powers of 4. When we combine these two checks, we get a superfast method that determines if a number is a power of 4 in constant time, no loops needed. Since the bitwise method uses only a couple of arithmetic and bitwise operations, it runs in O, 1, time. It also requires no extra storage, so the space complexity is O, 1, as well. Here's something to remember: loop-based solutions are great when you want to show your thought process clearly, especially in interviews. But bitwise solutions shine when performance matters, because they run instantly. Knowing both methods not only makes you versatile but also shows that you can approach a problem from multiple angles, a skill interviewers love to see. And that's how we solve the power of 4 problem. We started with a clear, beginner-friendly loop approach, and then we jumped into an optimized bitwise trick for instant results. If you enjoyed this explanation and want more problem-solving breakdowns, make sure you subscribe to BugNoJutsu, hit the like button, and share this video with someone who's learning algorithms. Thanks for watching, and I'll see you in the next one.